Derivatives aren't just formulas, they tell us how fast things are actually changing. In this lesson, we'll look at different applications of derivatives. What does a derivative mean? A derivative represents a rate of change, revealing the dynamic behavior of any quantity over time. For instance, if a function represents position, its derivative will be velocity, that is how fast location changes. If the function represents velocity, its derivative will be acceleration, how fast speed changes. If the function represents population, its derivative will be the growth rate or how fast the population is changing. Or if the function represents the cost, then the derivative will be the marginal cost, that is how fast expenses rise or decline. So the derivative represents the rate of change. Velocity is the first derivative of position, and acceleration is the second derivative. That is, if the function s of t represents the position, then we call s prime of t velocity function, which is represented by v of t, and the derivative of v of t, which is the second derivative of the position function, is represented by a of t, which stands for acceleration. Let's see how this applies through this example. Let's calculate velocity and interpret what it means when an object moves according to a position function. So given the position function s of t equals t cubed minus 6t squared plus 9t, and that is in meters, in order to find velocity, we'll find the derivative of the function. So we'll call it v of t, which is essentially s prime of t, the derivative of the position function. That will be equal to 3t squared minus 12t plus 9. So if we want to find the velocity at time t equals 2 seconds, we'll simply substitute t for 2 into a velocity function. So v of 2 will be equal to 3 times 2 squared, which is 4, minus 12 times 2, which is 24, plus 9, and that will be equal to negative 3. So what does that mean? The velocity is negative 3, and that will be in meters per second, meaning that the object is moving backward because the velocity is negative at the particular time t equals 2 seconds. When we have a quantity q of t, its derivative q prime of t tells us the growth rate. That is how quickly that quantity is increasing or decreasing over time. This concept applies to populations, investments, resources, and countless real-world scenarios where change matters. In this next example, a town's population follows p of t equals 1,000 plus 50t squared, and that is in people. So let's find how fast the population is growing at year 3. So our population function is p of t. In order to find the growth rate, we'll find the derivative of p of t. So p prime of t will be equal to 100t. And to find how fast the population is changing at time t equals 3, we'll substitute 3 for t into p prime of t, and that will be equal to 100 times 3, which is 300. So what does that mean? The population is increasing at the rate of 300 people per year at the 3-year mark. And here we have the graph of the function at the 3-year mark. Is right here. You can see that the population is increasing. In this next example, we'll see the negative growth, or we call it decay, because not all derivatives are positive. When a derivative is negative, it indicates decay or decrease, that is, the quantity is shrinking over time. So given the function c of t equals 500 minus 20t squared, if we want to find the rate of change, we'll find the derivative, which is c prime of t will be equal to negative 40t. And at time t equals 4, for instance, c prime of 4 will be equal to negative 40 times 4, which is negative 160. So depending on the units here, what that means is that the quantity is decreasing because we have a negative derivative, it's decreasing at a rate of 160 units per time unit. So if time was in seconds, that would be per second. If time was in years, that would be in years. The negative sign, once again, tells the story of decline. Understanding the sign and units of derivatives is crucial for interpreting real-world meaning. Here's your quick reference guide. If you have a positive derivative, the quantity is increasing over time. If the derivative is negative, the quantity is decreasing over time. And the units matter. Always check units to understand the rate. Let's say meters, it could be meters per second, meters per minute. If you're talking about people, it could be people per year, people per week, and dollars usually is dollars per unit, but it could be any other unit, so make sure that you use the proper units. Here's your challenge for today. A particle moves according to the position function s of t equals 4t squared minus 2t. Can you analyze its motion? First question, find the velocity function v of t. Then find the velocity at t equals 1. Is the object moving forward or backward? Take a moment to work through this problem. Derivatives are no longer just abstract formulas. You now understand they represent rates of change in the real world. From velocity to growth rates to decay, you can interpret what these numbers actually mean. And if derivatives finally make sense, hit like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.